Now you have two layers of muscularis externa, the inner circular and the outer longitudinal. Here's a closer up picture of just mucosa. So once again, here to here is mucosa, zoomed in. Mucosa, I might have to identify that tissue type from here to here. A stratified squamous epithelium. It's really squamous up here. When you evaluate a tissue, you just kind of look at the apical layer. It's not the layers down here. These are the layers where you get the cell division between close to the top. The whole thing is an epithelium. Stratified squamous epithelium. This is a connective tissue underneath. All epithelium have a lamina propria underneath it. This is smooth muscle. It's muscularis mucosa. So below that is submucosa, and you can see some lens in the submucosa there. This is also esophagus. Again, this is the mucosa, the stratified squamous epithelium, lamina propria, muscularis mucosa, submucosa. This is the circular layer of muscularis externa. This is looking at the full thickness of muscularis externa. The circular layer and the longitudinal layer. Moving on. This is stomach. So if I ask you, where in the GI tract are we? Stomach, it's a sideways view. The same general pattern. Mucosa, this loose connective tissue is submucosa. From here to here is muscularis externa. There's supposed to be three layers, but I can't make them out. So I won't ask you to. Just know that as muscularis externa, the whole thing. From here to here is serosa or adventitia. Now in stomach, so in the mucosa, I might also have you identify gastric pit, gastric gland. There's gastric pit. There's gastric glands, even the epithelium here. Closer a picture of that. There's the pit. There's the gland. Here we see muscularis mucosa. Here we see a loose connective tissue, submucosa. This is still stomach. It's a different region. You don't have to know which region. I don't even know. They're just stomach to me. And you know the pits up here. And down here are gastric glands, gastric pit, gastric glands. That's muscularis mucosa. Therefore, what layer is that? Submucosa. It's a loose CT. That's the layer, submucosa. Okay, this is the muscle layer of this stomach. Okay, so this, So this picture we just looked at, we're looking more down here at the muscularis externa. You're supposed to see three muscle layers of muscularis externa here. I'll point them out to you. The innermost one is oblique. The middle one here, this is a circular layer, and this is longitudinal. Once again, oblique, circular, longitudinal of muscularis externa. Same thing. Here we see all the layers. Here to here is mucosa, with the gastric pit, the gastric gland, and muscularis mucosa. Here to here is submucosa. Here is the oblique, circular, and longitudinal layers of muscularis externa. I don't see serosa on here. Gone. This is just muscularis externa of the stomach. Again, the three layers, oblique, circular, and then this one longitudinal. Okay, that's still stomach. Moving on from stomach to duodenum. The small intestine has three parts, duodenum, jejunum, ileum. This is the duodenum with the mucosa. You can see the villi. Okay, here in the submucosa, you can see Bruder's glands. I'll have you identify those. That structures in the submucosa. Here's muscularis externa, circular, longitudinal, and this is serosa or adventitia. Remember, that's duodenum. This is jejunum, but only showing you the mucosa. You can still see villi, these finger-like projections. You can see down here we have intestinal crypts, and there's a reddish cell called Paneth cell. So this structure, this is still the epithelium of the mucosa. It's basically intestinal crypt with Paneth cell. Okay. So this is villi here, crypt down here. This is jejunum. Those intestinal crypts is how you tell jejunum. Let's take a closer look at the intestinal crypts. These are intestinal crypts. The reddish color cells, we call them Paneth cells. So basically it's intestinal crypts and the cell type is Paneth cells. Those The villi and crypts, they help the absorptive capabilities of the intestine. This is jejunum again. Again, this is duodenum. Yeah, you don't really have those. I wouldn't ask you intestinal crypts on here. Here I ask you Brunner's glands for, For duodenum, I usually ask you to identify the Brunner's glands. For, push the wrong button. For jejunum, I would ask you to identify as a structure the intestinal crypt and Panna cells. There's the crypts again. For ileum, which this shows, the ileum you see malt. The malt are the big, you can't miss it, purple splotches. Mucosa-associated lymphoid tissue, you see it dominates the submucosa, and it is even associated with mucosa. So from here to here is mucosa. That pink line, what do you think it is? Muscularis mucosa, muscularis mucosa. So from here to here is submucosa. So from here to here, what is it? Muscularis externa. You have circular and longitudinal. I clearly see two layers. I don't see serosa. This is ileum. So once again, small intestine, it starts with, in this slide set, duodenum with the Brunner's glands, jejunum with the intestinal crypts with Panna cells, ileum with the malt. Ileum malt, then we got colon. This is colon. The layers are mucosa, submucosa, muscularis externa, circular, longitudinal layers, from here to here, serosa or adventitia. Colon has malt. That's malt of the colon. So it's the same layers. That's all mucosa, these tightly packed tubular structures to compact feces. There's a submucosa there, a very pronounced muscularis externa, because you're trying to compact the feces to move it along. So you need a big muscle layer there. What layer is that specifically? Circular, longitudinal. Now, I want to take a close-up picture of these here. There's a lot of goblet cells in the mucosa of the colon. They're very important. I heard of a case where a man lost I forget the disease, but he lost the function of his goblet cells here in the colon. And he depended upon enemas for his whole life. He couldn't move his own bowels. Those goblet cells are very important. And one of my colleagues, who back in her nursing days, did home visits to do his enemas, she would only go once a month. So this guy would only have bowel movements for once a month. And I'm surprised the distal colon can hold that much, but it can't. And she described, all the stuff came out. And I think the surprising part was not that he lost the function of the goblet cells, that he was able to keep this a secret from his family. His wife and kids are all grown. They never knew. Decades of marriage, and they never knew he had some nurse coming over and giving him enemas. It's kind of crazy. I thought that was an interesting part. That's the physiology part. But needless to say, you might have to identify the goblet cells. They are very important for colon function. That's it. That test is online tonight, Friday, for 50 points.